and this talk is about visualizing knowledge graphs, and I'll just share my screen now. Okay, can you see my screen?
Yes.
Great. So my name is Duncan Grant, and I'm a solutions engineer at Logic. I've worked with knowledge graphs since I was at university about 9 years ago. Semantics, linked data is what I did my dissertation on. And then from about 5 or 6 years ago now, I joined Cambridge Intelligence, where I worked on keylines, which Marco may have introduced in the beginning of this, but I did used to work with Marco as well. So there's going to be graph visualization in this talk, as well as knowledge graphs, and I do have some demos which I hope people will find interesting about the evolution of music and also about researching and developing new drugs. So when we think about visualizations, we're thinking about ways of framing and enhancing our understanding of the information. So we want something that's going to be more useful than just viewing a tabular view of the data, and at the same time, it's not intended to be visual art. There has to be some way of giving us quicker time to understanding than we would otherwise get. And to start this presentation, I'd just like to go through a few basic rules of visualizations. So when creating a visualization, first question you may want to ask is, do you really need to see everything? So showing huge amounts of segments or huge amounts of data points in one visualization is not very helpful, especially when that visualization is non-interactive. Bar charts with bars behind each other, again, you're not really going to see what's going on here. It's nice to try and show all the data at once, but there are better techniques for displaying the information. You also don't want to distort perspective. So in this example, we have 3D pie chart. Again, it's showing too much information. A general rule of pie charts would be never show more than 4 segments at a time, because it's very difficult for the human eye to perceive angles. On bar charts, at least, you can determine small differences between bars, but it's very difficult to see that in pie charts. And 3D pie charts take this into an even greater level, because we have extra space, which is this 3D bit at the bottom of the pie chart, which is not lending anything to the visual display of the data, but it's still occupying the space and perhaps distorting our perspective into thinking this segments at the front are actually more important than segments at the back. And 3D pie charts on a 2D graph take that sin to an even greater level. 3D pie charts rolling across a globe, again, this is just crazy visualizations, and we don't want to do things like this. And in general, we would want to avoid all these kinds of visualizations. Also, when you're creating visualizations, perhaps the most important part is to be aware of biases. So when you're creating visualizations, there's always going to be some journalistic intent. How you're presenting this information to the user is important. You're going to be naturally including some kind of bias in how they will interpret that data, but you want it to be as accurate as possible. And in this case, this was a Canadian election, and the person who was creating this graphic for the TV obviously thought the Liberal Party was more important than the PC Party, even though they both had 37.5%. So for knowledge graphs, when we talk about knowledge graphs, what is a knowledge graph? Maybe a show of hands, who here is familiar with the term knowledge graph? Okay, a few people in the audience, but not everyone. So I think a knowledge graph is a bit of a buzzword term, in the same category perhaps as big data. It does have some meaning, however. It originally came from Google and the work that they were doing in terms of connecting different links together on the website on the web. But a knowledge graph, I think, can encompass all kinds of things like semantics, linked data, ontologies, and graphs in general. So that's kind of how I'm going to be focusing this talk. And the visualizations I showed at the start were general visualizations, but from this point on, really I'm going to be focusing on graph visualizations. So to give it a bit more context of a knowledge graph, we have this idea of triples. So every single fact about data can be distilled down to this triple, which is the most atomic level of data classification. In this case, if we were trying to define a triple about a band called The Clash, we could say that this band, The Clash, has a genre of punk rock. And we split these triples into subject, predicate, and object. So the predicate is the kind of link between the subject and object. And the DBR, DBO prefix, which you may see, is just a way of, shorthand way of describing the ontology, describing that data. DBpedia is a great resource because it's a massive knowledge graph. DBpedia is the linked data or the knowledge graph version of Wikipedia.
Just a sec, Duncan.
Okay.
I'll try to plug the audio, so maybe we'll amplify. Try now. No. No. Just a sec, because the audio was a bit... Okay, try now. No. Sorry, guys. Okay. I'll restore as before. So, yeah, now it should be okay.
Okay.
Yeah.
Is this better?
Well, yeah. Let's.
Okay, I will try and speak as clearly as possible.
Okay.
So, DBpedia is the knowledge graph version of Wikipedia. If you go to a page on Wikipedia, you may have seen those info boxes on the right-hand side, which give you extra context information about the page you're looking at. So, for instance, if you were looking at the Wikipedia page of punk rock, you may see an info box telling you punk rock is a derivative of bubblegum pop, rockabilly, hard rock, and all these other genres. So this is telling us the kind of musical origins of punk rock and the genres which came before punk rock. And at the same time, there's also information telling us that punk rock is influenced these genres. So we have post-punk, alternative rock, grunge, gothic rock, and all of these music genres. And by using that information about different music genres, this has kind of inspired me to describe a way of showing the evolution of music genres, which music genre influenced which, and how we can show that. So knowledge graphs are great because it's very easy to create a triple, and this concept of creating triples is massively scalable. When we go back to that idea of describing punk rock, we could have hundreds or maybe thousands of triples all describing different areas of punk rock, different things about punk rock. Ontologies are very robust, and they are really good when you're trying to integrate different data sets together. And Sparkle is a query language specifically for these knowledge graphs, and it's very powerful, and it's an open standard under the W3C. So it's a great tool for developers to use. So with this idea of which music genre has influenced other music genres, I could send a Sparkle query and download all the triples and visualize that. And to do this, I will create a Sparkle scraper, just written in Node.js, simple script to send Sparkle queries to dbpedia and get back JSON response of all the music genres. And I'll save that into a JSON file and just load that file directly into my web application to visualize the music genres. And then doing that, we end up with something huge and messy like this. And of course, this is not very useful. When you're dealing with network visualization, the very first thing that you're always going to want to do is to have some way of interacting with the chart. So just visualizing the triples literally is not helpful. When I mentioned that punk rock has hundreds or maybe even thousands of different triples connected to it, we don't want to visualize those triples literally because it's not very helpful to the user. Instead, we want a way of bundling things together and perhaps presenting the information in an easy to consume way, or at least searchable and interactive to the user. So this idea of triples on the back end is great. However, on the front end, it's not very human friendly. We need to think a bit more about how we're going to present this to the user. We need a way of maybe a new model of representing the UI. We need to think about properties for each node. So what the label should be, for instance, whether there's other decorations needed. Styling as well. Styling is something you're never going to store in a database, but you want to have colors or icons to help inform the user. And relationships, we could consider bundling nodes together, bundling edges together if there's many relationships between two nodes. Or we could perhaps present extra information on the edge, a label or other properties there. And there's definitely a need to interact with the data. So with that, I'm going to go ahead and show the first demo I have planned. And this is the first demo I have. So this is the triples we were just looking at on that black and white graph. But I have this loaded into D3 now. And when we zoom in, we can see the different music genres that are here. We have modern soul, we have teen pop, we have sunshine pop, all these other music genres. And still, it's not a very helpful view, perhaps, but we can begin to search through this. So if I was to search for punk, we end up with a number of different auto-suggest examples. And I could perhaps click on most popular genre, which is punk rock, and the graph will zoom into that and color the nodes differently. If I focus onto the chart, I can then see the actual sphere of influence of punk rock very clearly. So I can see which genres have directly influenced punk rock based on their arrow direction, and I can see which other genres punk rock has influenced itself. So punk rock is quite an influential genre, just looking at the number of connections. So does anyone have a particular genre they would like to see? Classical?
Yep.
So classical, we've got a whole range: neoclassical metal, neoclassical dark wave. Perhaps classical music will be the most popular there. And we can see where that is located. We can focus on classical music as well. Perhaps less of an immediate sphere of influence, but I imagine classical music obviously is created hundreds of years ago, so if we were looking at further than immediate connections, we would perhaps see something different there. And just to go back to that example of classical music, we can see there's a whole range of very strange classical music genres you may never have heard of. Neoclassical New Age music. We can go on to this one. Oh, and perhaps we're saying that neoclassical New Age music was influential on symphonic metal. So that demo was created in D3, and it's available on GitHub, and I will share the link at the end. D3 is very popular for visualizations in general, and it's a very flexible toolkit, but you do have to do a lot of work yourself, and particularly when it comes to more advanced features, even just filtering the charts like that, I have found it to be quite a struggle in D3, so the developer experience in network visualization at least is not the smoothest. I did do a demo of this also in Keylines, which is the company that me and Marco used to work for. And when I put it into Keylines, I had access to more features. So I ran a betweenness centrality measure onto the same data. And this lets me see not just the immediate connections, but which music genre influenced other music genres, which themselves were very influential upon other music genres. So looking at the whole graph, which music genre is the most influential of all time? And I will reveal that now. And it's punk rock. So presumably punk rock is very influential because it influenced glam rock and post-punk, which are both very influential genres in the 80s and 90s. And there's a whole range of other genres which punk rock directly influenced. So apparently punk rock is the most influential music genre of all time. And just to look at keylines, some other features we could incorporate would be things like grouping. So being able to group nodes together is another feature when you're dealing with very large networks like knowledge graphs. Filtering and grouping are two of the key areas you'd want to look at. So of course there's many limitations in the project I just showed you. We've got a very small scale data set, just a few thousand nodes and links. It's a static data set because we're just loading in a file. It's not very scalable and it lacks the features of search, security, also showing non-connected data, which you'd probably have in a real-world project. Any kind of versioning of that data and metadata as well kind of gets lost.
So, graph visualization options, we added the keylines and D3. There's many other options available as well. Drawing nodes on a whiteboard. When I was working for Cambridge Intelligence, I did speak to one customer who was upgrading their drawing nodes on a whiteboard to keylines. So that was a massive evolution for them of a couple of hundred years. But we also have other open source alternatives like ingests, which we'll be looking at in the next example. So the project without those limitations which I just discussed in the previous slides is the Biologic Pharma Research Hub. So this is a project which I was working on as well. And the idea is to provide a single pane of glass that provides an area for a researcher to search for topics that help them research and develop new drugs and bring to market. For most pharmaceutical companies, the average time and cost to bring a new drug to market is 15 years and $2.6 billion. So anything they can do to improve and accelerate the R&D process is hugely beneficial to them. They've got a number of research challenges as well about not easily being able to search over all the information they have, not being able to make sense of it and show all the connections, and also being able to collaborate with other researchers. So I will show you a demo of this now. This is an example of the Pharma Research Hub. In the interest of time, I will give you just a quick demo. The idea is we have loaded in here authors, publications, drugs, genes, and proteins, all publicly available sources of information. But the real value comes when an organization integrates their own data. So don't get hung up on the data that's actually in here. Being able to integrate their own data is also hugely valuable in this system. But I could search for a publication, particular author. We have a normal search result page here. I can click on it and get the information about that publication. We have topics, which are automatically extracted from the text. And we also have a graph view. So the publication I searched for here, all of the topics which were extracted from this text are shown as relationships. What we could do as a more interesting search would be to copy these gene names which were found in the paper and just do a search of all of those. So I can type in 4 different genes and search across those. We can see the 4 genes being displayed in this view. But we can also see the same search results displayed in the graph view. So the 4 genes that I've searched for are now being displayed on this graph as these orange DNA symbols. And there's quite a lot of interactivity I can do on this graph. There's a lot of publication notes currently being shown, so I can right click on one of these and we have a context menu. So the 2 typical ways of interacting with a network chart would be context menu or perhaps a sidebar or other toolbar. In this case we have context menu. I will just hide all those publication notes. Now we have the chart just showing those genes and the proteins which target those genes. So when you're developing a new drug, typically the drugs will act on the protein, which itself is developed from the gene. So I can also interact with the database here. When I double click on a node, it's going to query the database and load in any immediate relationships to that. So I can see one of the proteins have no connections, but the other ones it reveals further connections. So whereas for my initial search I had no connection between the 4 genes, now I can see the group between them. I can see drugs that have been developed. I can see the different relationships between these proteins. In this case, these 2 proteins are connected by some drugs they have in common and also in the same protein family. So we're using glyphs here, which are these extra symbols to indicate it's a protein family. And the idea is by showing colors and icons and then sub-icons, we're able to give much more context to the user without cluttering too much information and helping people understand how their research is connected. And we can see this node up there is connected to 2 proteins and it has a label internal to demonstrate that that's you can load internal and external information. And you can see where the sources are coming from. So one of the rules of network visualization would be to use as few TPs as possible to show the maximum amount of data. And by this I mean the icons and colors and links between them. Of course, there's a lot more information that sits behind this. If I right click on a drug, we have all these other options, and I can see the detail in the view tab. So we can see all the information related to this drug. And of course, it's far more than we would actually want to show in a graph visualization. But the information is there, easily accessible when the user wants to come across that. There's also a number of different facets you can do, and you can also bookmark different things and collaborate with users. So there's a lot you can do in terms of working with links between research data and sharing that information. So the demo I showed is powered by the Data Hub, which is a data platform for ingesting any kind of data, structured data and unstructured data. You can load in PDFs, XML documents, database dumps, whatever it is. And then within the Data Hub itself, you can begin the process of data curation. You can use semantics. You have excellent search and indexing by default. Everything will be indexed. Very strong security and governance, and the ways of harmonizing the data once it's in the data file. there's no costly ETL process on front. Once the data is in there, you can start working with it. And perhaps interesting for the graph community would be the semantics. So you can load in triples and RDF as they are, but you could also enrich the data you have there with triples. For instance, if we load in a publication PDF document, which is completely unstructured and not very useful as it is, we could, within the data hub, start defining triples about that publication. So I could, for instance, say this publication has these authors connected to it, and we can start building up the knowledge graph that way. Also great in logic, and we used in the Pharma Research Hub project, is this idea of data services, which you can think of as microservices running within the graph container. So we can collect the data from all the different sources within the data hub, harmonize that together, and output it in exactly the format we want. So for the Pharma Research Hub, we just send a HTTP request with an ID of the node we want to look up, and then the data service returns JSON in Vue.js format that we can load it directly to the graph visualization without having to do any further processing on the front end. So key points from this presentation really are, when you're looking at knowledge graphs, semantics, or linked data, there really needs to be a different model from the front end and the back end. Using something like data services, or if you're not using logic, some kind of microservice where you can get the data in the right format and separate those responsibilities for back end versus front end. It's very helpful and helps you to be more agile as you develop. Let the user focus on what they want to see by making the chart as interactive as possible. And also, the graph on its own is not usually enough. So having some traditional search interface, having some documents with more context is usually more helpful than just having a graph on its own. So thank you very much for listening to my presentation. You can find me on Twitter at the Web Nomad, and if you're interested in the music genre project, you can find that on GitHub as well. And if you have any questions, I'll be happy to take them.
I would say first thanks, Duncan. Anybody has any question to ask?